Okay, so for the last problem, we have a cylindrical tank. So, the velocity with which water will flow from a small orifice in a tank at a depth h below the surface is 0.6 square root of 2gh feet per second, where g is equal to 32 feet per second square. Find the time required to empty an upright cylindrical tank of 5 feet and reduce 1 feet through a 1-inch hole in the bottom. So, for us to understand, we're going to draw the tank. So, meron tayong tank that is, meron tayong tank that is 5 feet in height, 5 feet in height, and then 1 feet in diameter. Ngayon, meron daw siyang orifice. Ang orifice ay opening at the bottom. So, opening at the bottom of the tank ay 1-inch hole. Meaning, pag 1-inch hole, ang ating radius ay 0.5 inches. Ngayon, since wala siyang sinabi kung hanggang saan yung depth, assume natin na punong-puno yung ating tank. So, at yung tubig ay lumalabas siya dito, 'di ba, sa ating orifice. Na ang speed ng orifice ay 0.6, ang speed ng water sa ating orifice ay 0.6 square root of 2gh feet per second. Ngayon, ang tinatanong, ilang time bago maubos yung laman ng ating tank. Okay, so ang gagawin natin, since ang gagawin natin, class, is meron tayong h. So, gagawin natin, h is time, h is the height at time t, at any time t. So, h is the height at any time t. So, h is our height at any time t. So, paano natin makukuha yung ating time? So, class, pag at any time t, bumababa yung ating tubig, di ba? Bumababa siya sa value ng dH. Sa bawat pagbaba ng tubig natin, yung nawawalang value, nawawalang tubig dito sa ating tank, yun yung volume naman na lumalabas sa ating orifice, di ba? So, yung nababawasan sa tank, yun naman yung volume na lumalabas sa ating orifice. Ngayon, ang gagawin natin, volume loss in tank is equal to the volume out sa ating orifice. So, ang volume loss natin sa ating tank ay yung volume na, yung anong volume ng tank natin, class? Area times height, diba? So, pi, ang kanyang radius ay 1 feet squared, at ang kanyang height na loss ay dH. So, gagawin nating negative dH yan. So, squared, kasi loss siya, bumababa siya, negative dH over time, dt. And then, ang volume out naman natin is yung area ng ating orifice, that is pi. Ang kanyang radius ay 0.5 over 12 squared times yung kanyang velocity, 0.6 square root of 2gh. Okay. So, parehas na may pi, ika-cancel natin. Nagiging negative dH over dt is equal to, ano yung g? 32. So, 32 i-substitute natin. 2 times 32 is 64. Square root of 64 is 8 times 0.6 times 0.5 over 12 square. 1 over 20 square root of h. Ngayon, ang gagawin natin, like terms, h square root of h 120t negative, and then integrate natin yan, magiging square root of h over 1/2 negative 120 dt ito. Bakit niya naging t? 120 t plus c. Okay? So, magiging 120 negative 240 square root of h is equal to t plus c. So, t is equal to negative 240 square root of h plus c. Ngayon, ang gagawin natin, kunin natin yung ating c. When t is equal to 0, ano yung height ng ating tank nung wala pang nababawas sa ating orifice? That means h is equal to 0. That means h is equal to 5 kasi punong-puno pa siya. So, 0 is equal to negative 240 square root of 5 plus c. So, ano ang c? 240 square root of 5. So, ang t natin is equal to negative 240 square root of h plus 240 square root of 5. Ngayon, kapag wala nang laman yung ating orifice ay yung ating tank, meaning, ang h na natin dyan is, change color to. Ang h na natin dyan ay 0 kasi nga wala nang laman, 'di ba? Bumababa yung ating water. So, pag wala na siyang laman, h is equal to 0. Ano yung ating time? So, ang gagawin natin is substitute natin t negative 240 square root of 0 plus 240 square root of 5. Square root of 0 is 0. So, ang magiging t natin ay 240 square root of 5. That is 240 square root of 5. 536.66 seconds. So, kung kukunin natin yan in minutes, divide it by 60, it is 8.9 minutes or approximately 9 minutes. Okay? So, para mas maganda yung answer, sasulat ko ulit. T is equal to 240 square root of 5 seconds, approximately 9 minutes. So, the question, class, what time? Find the time required to empty the upright cylindrical tank. So, para maubos natin yung tank, class, is, maubos natin yung laman ng tank, it is 9 minutes. So, yun lang, class. Kaya natin siyang isolve, di ba? Kung anong time mauubos yung laman ng tank. Anong kailangan natin? Dimensions of the tank, dimensions of the orifice, and the initial volume of the orifice. So, yun lang. And then, makukuha natin that the initial time, ay the time required to empty a tank is 9 minutes. So, that's our last example for the applications of indefinite integrals. So, this one, class, you're going to solve this one given yung question and then given yung answer. You'll just have to prove the answers. So, this is 11 to 20. So, you'll have to prove these answers. And then, we'll proceed to our next lesson, which is definite integrals. Ibig sabihin nito, ito na yung integral na meron ng limits. Okay? Kaya siya tinawag na definite. You're going to answer this one and you're going to pass it, class, on our next meeting. Okay? So, the deadline will be shown on Schoology. So, you're going to solve this one. Ito na, class, para i-practice nyo. I am giving the answer for you to practice. Don't just do and copy this one. So, ito na yung gist ng ating pag-compute ng calculus, the applications of calculus. On your higher year class, you'll appreciate calculus more. Kasi, halos lahat ng isa-solve natin is merong calculus. Okay? Especially the last one, ma-apply na to sa fluid mech. Okay? So, thank you, class. If you have any questions, you can ask on our group chat or on our Facebook page or on our page in the Schoology. Okay, so that's it. Thank you.